Hello and welcome back to the Embedded World 2023 and to the exhibition forum in Hall 3. Now on the list we got an expert panel on sustainability and IoT.
Okay, so good morning everybody. My name is Dirk Pesch. I'm a professor in the School of Computer Science at the University in Cork in Ireland, and I'm the moderator of the panel this morning, and I'm delighted to introduce 4 panelists. We have 3 in the room here and 1 panelist online. So our first panelist is Dr. Rolf Riemenschneider, who's head of the area Internet of Things with the European Commission in their scientific directorate. Rolf's unit is responsible for the deployment of data spaces under the Digital Europe program for mobility, energy and agriculture. And after publication of the action plan on digitalization of energy systems, he's also deeply involved in this particular topic. And that's really kind of part of what the panel is about today. Then online, we have Monsieur Laurent Schmidt from Digital for Grids, which he has. He's online. I don't know whether you can. It's not shown there. Can we? Oh yeah, excellent. Laurent Schmidt, who is president of Digital Grids and provides consulting and new demand response orchestration platforms for grid operators. He's been working for the last 25 years in automation, IT, and digitization of the power industry. Then we have with us Dr. Peter Spies of the Fraunhofer Institute of Integrated Circuits here in Nuremberg, where he is where he works on multi-standard front-end system simulation and communications applications, and he's the manager of the groups on integrated energy supplies. So this is kind of our sustainable IoT focus. And then finally, Dr. Lena Yoshihara-Liesch, who is Chief Innovation Expert with Deal Metering in Germany. And Dr. Liesch is a mechanical engineer with a doctorate from the Technical University of Munich. And she is responsible currently in Deal for a lot of the connectivity solutions for metering. So the panel today is looking at sustainable IoT, looking at how can we make IoT systems and devices more sustainable, but also how can IoT be used to make our world more sustainable. So we have representatives from both camps, and what I'd like to do is I'd like to hand over to our panelist to give an opening statement, and we'll start with Dr. Yoshihara-Liesch.
Thank you very much for the introduction, and welcome everybody. So as said, the 2 topics today will be both how can we use IoT to drive sustainability, and also how can we make IoT sustainable. And I'm coming from a metering background, so water and heat metering, and I think it's a perfect example for both. So I mean, we see an increasing trend of metering coming smart, IoT and metering growing together. So the times where people go into your basement once a year to read the meter, they will be over in the future. So it's more about creating really data that can be used in terms of sustainability. And here metering, smart metering can really help you over the whole chain to increase sustainability, and also to make a sustainable use of our precious resources. So you all know we're having climate change, energy crisis, water scarcity. So these are all topics in the media. And with smart metering solutions, what you can do is, starting from on the end consumer side, increase awareness and transparency about the consumption. Then over the supply network, using frequent data, you can use it to make the network more efficient, to detect anomalies, for example, to detect leakages. And so then in the end, also finally on the production side, that you can better adapt your production to the demand. If you use frequent data, combine it also, for example, with other data that is available to really make predictions to the future. So that's the one part where you can use IoT in terms of a sustainable solution. But on the other hand, of course, you also need to think of how can you make your IoT, your smart metering solution sustainable. And in 75% of all metering use cases, you do not have power. Like, okay, in the electricity, it's rather clear you always have power. But for water and heat, it's usually not the case. So you have battery-driven devices. And that's also, of course, a challenge. If you want to have the frequent data, you also need to think of which technologies you can use there. And there are several on the markets, which I guess we can discuss later on.
Yeah, thank you very much for the opening statement, Dr. Spies.
Yes, so actually we are working on the field of powering IoT sensors. So IoT sensors, from my point of view, are a very important part of the Internet of Things. They gather the data which are needed to make all kinds of systems or all kinds of functionality very efficient. And these sensors are used in different kinds of application, in the metering applications. We also have sensors in any kind of buildings to make the buildings smart and energy efficient, and we have a lot of sensors, for example, controlling vehicles, controlling the traffic, or monitoring and controlling any kind of machinery. And also there, the goal is to make these machines, to make these vehicles very efficient, to control the transfer, the logistics, and to save energy. But on the other hand, we have also to be careful with what kind of electronics we are using for these IoT sensors, and what do these sensors consume during their lifetime, but also what kind of environmental burden these sensors produce during the production. So how many chips do we use when we produce these sensors? During the lifetime, it's very easy. We are working on energy harvesting. Energy harvesting means we use energy transducers like solar cells, thermoelectric generators, or vibration harvester, and we're using environmental energy in the direct proximity of the sensor to generate electricity. So during the lifetime of the sensor, there is no CO2 impact on the environment because we use regenerative energy sources. A little bit more challenging is the production phase and the environmental the burden which is produced during the production of the semiconductor devices or during the production of the electronics. Here we have to be careful how often we do have to update the hardware, how often we do have to produce new hardware, because each new hardware, each new version of the hardware produces an additional CO2 impact by the production of the semiconductor technologies. Thank you.
Okay, thank you very much. I'll hand over to Rolf.
Yeah, thank you. So it's a pleasure to be here. As I said, I work in the European Commission in the unit Internet of Things. And we heard about some innovative components, and we tried to set the umbrella for sustainability and energy efficiency. So basically, the sustainability goals of the ITU is part of the DNA of the von der Leyen Commission. I think that was from the beginning, and they launched a Green Deal, and now during the crisis, these sort of measures have been amplified. We talk about Fit for 55, to reduce energy by 30% until 2030, and we talk about other measures. So actually, the ICT industry is consuming itself energy, as you said, but I think we have figures that the ICT contributes 7 times more on energy efficiency than it consumes itself, which is not an excuse, of course, that the ICT has to be energy efficient, but I think there's a huge amplification leverage through the use of ICT in different applications, from water monitoring on our buildings. So we try to have that umbrella to connect to different policies. You will hear about energy in a second. We talk with DG Agri on sustainable farming. We talk about sustainable buildings and sustainable mobility. This said, we also support research and innovation in IoT towards edge computing. So edge computing, what does it mean? I think you keep the data local. You have a local processing. You avoid that the data travels around the world, which reduces the energy footprint on the one hand, reduces the attack surface, having more security, and contributes to operational efficiency. So that's part of the research and innovation program, what we call Horizon Europe, our research and innovation funding program, where we talk about decentralized intelligence, having more computing capacity at the edge, in order to leverage the power of computing as well as the innovation on the sensor level. So this said, these issues have also an impact of buildings, because building works on the cross-section between different application areas. Nice, living, comfort, reducing resources, water, electricity, but also sooner or later also to have your electric vehicle charging at home, or you put solar panels on the roof. So what are the burning issues at the moment is to have the adoption of components, but also to have the link between different ecosystems. Because if you keep everything separate, the user has an impossible role to integrate the systems in order to have a benefit. And then we're working on the cross-section, again, looking at standards and technologies in order to link the different sectors, ecosystems, and to have a leverage effect.
Okay, thank you, Rolf. Finally, Laurent Schmidt with his opening statement. Laurent, over to you.
Thank you, and apologies for not being here. There was a few points I wanted to make as an introduction, as what Rolf highlighted is really the rapid pace of introducing renewable into the energy system to reach the net zero objective. So that will require 4 times more flexibility as what we call in the grid, so a new kind of interaction between the building on home and the grid itself. We already observe it into energy prices, where the volatility has significantly increased. So nowadays, if you've got a car with bidirectional charging, 10 kilowatt, for example, you can some days do 20 euros per day just by charging and discharging your car. And in the same time, the grids are also getting more complex to predict, more congestion, and so grid operators are looking at new flexibility markets. So edge computing here is very important. It's a great opportunity to integrate all these devices, as what Rolf mentioned, at the home level. I think what is important in the energy sector is the real-time element of it, the real-time broadcasting of information exchange across the various layers of citizens, grid operator, energy service provider. And one case which we are analyzing in great detail is really the case of smart home, where we think there is a new wave of innovation which comes largely related to PV self-consumption, so installation of rooftop PV, and together with your car, which is going to become bidirectional charging capable by 2025, and which is in the same time able to smartly react and participate into these new flexibility markets. So this is a very concrete example of all these layers, hybrid cloud down to edge and IoT, into helping the grids to decarbonize.
Okay, thank you very much. So I'd like to kind of start us off a little bit with a number of questions for our panelists, and then I'm hoping that you, the audience, you have lots of thoughts and suggestions and questions. But just to start us off, Rolf, we see, predictions of, this many billion IoT devices deployed by 2020, 2022, and so on. And in fact, the predictions actually have never come true. And to me, it seems that, there is, particularly in the smart home space, there is a lot less deployment there. Most people don't have a smart home. Most people don't have devices in there. We see a lot of fragmentation there. So what do you think is from your perspective, what do you think are some of the issues here?
Yeah, I think that's a good question. I think you mentioned we have more than 50 billion IoT devices by 2025. I think the devices are there, and you can buy it, in the supermarket, in stores and professional services. So the investment of 6 to 2 trillion euro in IoT is, I think, predicted. I think it's a real case. But within that prediction, you have investment into healthcare of 2.5 trillion and manufacturing as main drivers. And now, you have new applications like smart charging or smart solar. Where's the home? Where is the smart home? At the same time, we are in the energy crisis. I think the issues are burning. The buildings and construction sector accounts for more than 37% of CO2 emissions of all sectors. So there's a need to change. Particularly in Germany, there's a need or a requirement to reduce the carbon footprint of the building sector by 43% until 2030. 43%. It's more. So you have not much time left. So why is it not happening? As I said, we see a lot of fragmentation. We see that the building sector has a very low adoption of new technologies. If you buy a new apartment, if you rent a new apartment, you know what counts? It's location, location, location. So there's no incentive, you know, in order to modernize the apartments and to make it energy efficient. So that might change. Meanwhile, I think there are some game changers around. I think we have the energy crisis, we have skyrocketing energy prices, we have the CO2 tax, which comes along. There's a discussion now in Germany on replacing heating systems. You know, we're working on the individual devices. So I think there's a game changer around. There's a need to invest. But I think what I want to say, well, you know, there's a risk, you know, that again, the different investments rest in silos. That you have a heat pump, you have a solar, you have charging, you have a home automation system, you have a thermostat, and you know, and all that is not connected. And there, you know, IoT has again the potential, but we have to make it happen. And that is a bit of the challenge and why I'm happy to be here.
So we were talking about putting more IoT technology into buildings now to make buildings smarter and so on. But you know, I worry that we put all of this technology in, and then we have 100 IoT devices, and I spend every second day changing the batteries. So how can we get away from those challenges? So, Peter, what are your thoughts on how we can transition to a future where we have a sort of deploy and forget type approach to IoT?
Yeah, I think there are two ways to achieve these deploy and forget IoT. The one hand is, of course, power optimization of the IoT device itself. This is one part of the solution, so that just the semiconductor technology get more efficient. And the other hand, of course, is not relying on batteries, but using ambient energy, which is available at the location of the sensor. And this is meant by energy harvesting. So energy harvesting uses ambient energy like light, heat, or mechanical energy, and generates electrical power to charge the sensor during its operation. So there's no need to replace or recharge the battery. There's also no need to provide cables to power the sensor. These sensors power themselves from the environment. And this is, on one hand, it is very economical, because these sensors are easier to install. I do not have to care for any power supply, for any cables. And on the other hand, during their operation, these sensors are completely CO2 neutral. They do not consume or produce any CO2 because they generate their own electricity without any CO2. I think that's a very good solution. And of course, the third part of the solution is also to really decide which data is important, which data has to be transmitted to the edge or to the cloud, and which data can potentially be analyzed on the sensor and just thrown away because it's not important for the application.
Thank you. So we're talking about this sort of IoT for sustainability, and so I'd like to ask Lena, you know, you're talking about metering, for example. So how do you see sort of not just electricity meters, smart meters which are being rolled out, but at a broader level, how do you see kind of smart meters for all sorts of applications supporting this kind of more sustainable future across all the utilities spectrum?
Yeah, so let me take the example of a water utility, so the water network. So usually if the utility just goes for billing once a year, to all the inhabitants, looking, okay, what was the consumption, they can make a water balance exactly once per year, meaning for the rest of the year they're going blind. In case they have any leakages, they will only detect them after 1 year or time span. And so that's very, very severe problem for them. And I mean, you might be surprised how much really the water losses are within a network. So if you compare the water that is produced and put to the supply network with the water that is actually billed to the end consumers, you really get a lot of non-revenue water. So that's how it's called, because it's produced and not billed. And we're not talking about third world countries. We're really talking about European countries. So for example, in Italy, the amount of non-revenue water is 40%. So 40% of the water that is produced doesn't reach the end consumer. Because, I mean, of course, you can also have fraud or something like that, but it's not that much a problem because we have very strict regulations. So it's really about water losses. France is 20%. Yeah? And so this is really a severe problem, and especially in these countries like Italy, where you see, I mean, it was just in the media, Lake Garda is falling dry, so they really have a problem with the resources, and so they are simply losing it over their network. And here, if you really have frequent data of your inhabitants, you can, on a very short notice, see, okay, here I have a problem. And if you also make the balance not just for the whole network, but subdivide it into smaller parts where you have bulk meters measuring how much water is supplied into that area, and then you compare it on a daily basis with what is consumed at the end consumers, you can see directly every day, okay, this is a red zone, I need to go there, I need to check for water leakage. Because mostly the leakages that are a problem are not the ones where you really have flooded streets. That's very simple, you just go there and fix it. But the problem is really the small leakages where you have dripping all over the time, which you cannot see. And here really getting the data helps you to detect these leakages. So that's one example. But also on the heat side, as I have said, it can help you to, if you have consumption data of the history, and you combine it, for example, with weather data, you can make a prognosis of the demand. You can say, okay, next week my demand is estimated to be that high. In 1 month it is estimated to be this high. And so you can adapt your production much better to what is really needed. And so you are resilient in cases where the consumption will be high, but you do not overproduce, yeah? Because that's often a problem in heat networks, that you supply a lot of heat, but it's not consumed. And then it's, so to say, lost. Yeah? And here, really having frequent data can help you to go into the sustainability.
Okay, thank you. So I'd like to ask Laurent, so you were talking about electromobility earlier, and where do you see IoT assisting and enhancing the whole electromobility space? I mean, I have an electric car, and you know, I kind of try to predict when would I charge it best, where do I get the, you know, might I charge it at work or might I charge it at home and so on. So where do you see kind of additional data points and information playing a critical role here?
Yeah, so I think it's around the charger and the way it interacts with the car. So there is a layer of data exchange which is critical, which is being able for consumer to access the level of charging of their battery as a starting point, and then being able to interact with the charger, like what you see behind me, which is really becoming a home energy station in the sense that it integrates as well potentially a standalone battery and a PV panel. And so then using edge computing into this device really allows to run edge optimization, making sure your car is first primarily charging with your own PV, but also interact with markets and flexibility prices so that you do not charge when the grid is congested. And so if you look at this use case as an example, it is becoming, as you say, rather complex for a driver to go through that. So what we hope the edge computing will bring is really a digital twin running at the edge of the grid, at the edge of the consumer, and providing advices or automating all this complexity of whether to charge, discharge into the home, but also best interact into dynamic prices. So this is really what we see coming as the big thing into the electromobility sector, is using your car not only for traveling purposes, which is very important, and of course you need to interact here more for charging in the street, superchargers and so on, but really optimize your charging into the home, because it is way cheaper to charge in the home. It's on average 1/3 of the price to what you charge on the street. So that layer is extremely interesting, and we see very interesting fast development from OEM car manufacturers, wishing, a majority of them wishing to be ready for that kind of use case for 2025.
Thank you. So, Rolf, you were talking earlier also about the edge computing space. And so where do you see this going? I mean, a lot of, you know, there's still a lot of IoT applications kind of rely heavily on the cloud. But clearly, in order to bring data closer to the the application space to reduce latency, for example, but also to look at privacy. You know, do we want to share all data with the cloud? Where do you see the edge computing going at the moment across the, you know, say maybe even the consumer, the end consumer space?
That's a good question. Where do we see edge computing going? I think if you go to the supermarkets, if you look around and buy an IoT device, first of all, you don't know even what's the connectivity, but 80% it will be wireless LAN. It goes somewhere to the cloud. And then, you know, quite a high likelihood, if it's a cheap device, there's a Chinese manufacturer. So you have a cloud somewhere in China. So all your data goes there, and you know you don't trust there. You try it out. It's a gadget. You know, it's just a consumer device. You have fun. Yes, and then you have a very short life cycle, and you buy it and you throw it away. So where's edge computing? So when is the consumer aware, you know, where I put my data? That is the first thing. The second is we talked about meters. I think the consumer is using the meter once a year, okay. But, you know, talking about energy management, flexible tariffs, you know, we need more adoption of the energy usage too when energy is available. So meaning, you know, we need an agile metering device. You talked about heat. When do you do heating of the water? When you can recuperate the heat of the water. What we talk about sector coupling. So we also need, you know, exchanging data, coupling the different sectors. So we need a device, you know, it adapts to the future services. And if you put a meter outside, electricity meter stays for 10, 15 years, though that cannot continue. Who will pay for that? So talk about edge computing, yes, a meter will have a capacity to produce the data local, so people are not worried that all my electricity data or the metering data goes to my provider and I have a login. But secondly, also, you know, we have to separate hardware and software. We put the metering device inside, and the hardware will stay for 10, 15 years. But we should be able to decouple the software and the services, that we allow, you know, an update of the software and the services, you know, by the innovation and the new services available, and to connect to emerging services. And that is a bit of the promise of edge computing. On the one hand, we need an ecosystem, interoperability of different devices, so you're not bound to install, I don't know, 5, 10 computing devices at your home in order to manage all these devices, that you can combine different things. But at the same, you have to be sure, you know, that you have support for your device for a certain period in terms of security updates, but also enhancing the functionality, decoupling software and hardware. And that will boost the lifespan of the devices, and will also increase the attractiveness of the devices for the edge.
Thank you. So, Lena, we were talking earlier about you know, connecting meters in a cellar and so on. So there are clearly connectivity challenges. And if you have a very large apartment block with everybody having their own meters, you get very dense deployments of meters as well. So where do you see the connectivity technology going to connect potentially in the future all of these, you know, millions of meters in urban environments?
As in general, I think it really depends on the use case, which technology is favorable here. And yeah, I mean, in the metering, it's actually, let's say, the most challenging IoT use case you can imagine, because you have the sensor located usually in the basement, so it's very hard to reach. You need to have robust technologies with a large scale, yeah, because it's usually not efficient to place that many gateways over a city, for example. It needs to be very robust and reliable, so there are a lot of, let's say, requirements regarding these technologies. And now you have different options, of course. I mean, starting from classical cellular technologies like narrowband IoT or LTE-M. Of course, you can use these, but the problem is, as I said, in 75% of the metering use cases, you do not have a power supply, so you have battery-driven devices. And all the beautiful advantages that cellular technologies bring, of course, also come at a price, and the price is that usually regarding the energy efficiency is perhaps not the most optimal technology, at least if you want to have it really in the broad area. And then, of course, IoT technologies now enter the metering market as well. So first of all, of course, LoRa, because, I mean, that's really, you have a large ecosystem there in place, a lot of experience with other IoT use cases. Now, this is also coming to the metering market. Yeah, but of course, also that technology has advantages and disadvantages. It was not specifically designed for metering. And so metering, you have perhaps longer telegrams than in classical IoT use cases or very simple IoT use cases where it's simply binary, for example, on, off, or full or empty, something like that. Metering is a larger telegram. And then, of course, if you have LPWAN technologies like LoRa in a license-free band, then you really have the problem of interference. Yeah, so the technology needs to be very robust. And that's something where LoRa actually very soon, if you have a large number of connected devices, reaches its limits. Yeah? And then you have newer technologies like next generation, like IoT, which overcome several of these disadvantages. So from the technology point of view, it's really superior due to the patented technology, which is actually developed at the Fraunhofer Institute here in the Nuremberg region. So that's the technology which really ensures that you can scale to massive IoT applications. So a lot of different sensors connected, large scale, large range. So this really has certain advantages here. But of course, we have to say it's a follower technology, so the ecosystem is not that developed at the moment. But I'm pretty sure this will come as soon as we have more and more IoT devices, as we just discussed, in the future to be connected. So, but in the end, I would say the world is colorful. There won't be just one technology. Yeah, that's of course also a question of fragmentation, as we have addressed. But in the end, it will be a combination. Yeah, so perhaps using cellular technologies in very hard to reach locations where it's simply not efficient to go via LPWAN technologies like LoRa or IoT. And you still have legacy sensors like LoRa, which you have in your network, and perhaps additional ones you add with IoT. So that's also a challenge for everyone who provides an infrastructure or who's operating an infrastructure to be prepared to this, because I'm very sure that this is what will happen in the future.
Yeah. Thank you. So Peter, you've been talking about energy harvesting, and your institute is one of the big players in this space, driving forward energy harvesting technologies. Can you give us a sense where do you think is this going in terms of, what are kind of new harvesting approaches that are coming out that seem to be getting traction? I mean, you mentioned, small solar cells, and we've had this, for quite some time in certain applications, but what else is coming there?
Yeah, of course. There's a lot of research going on. So when I started with that topic, I think it was 15 years ago. And most applications were just in the experimental status. So of course, solar cells are the most obvious ones. They work nearly everywhere, except you have some environments where you do not have light in general. And this is, for example, the metering use case where you have your sensors in the basement. But let me mention, it is not important that you have the energy all the time available. So these IoT devices do have some small storages. And so, for example, if you have light during during a certain period of the day for a couple of hours, then you can store the energy in a small battery in the capacity, and then a capacitor, and then you can power the device during night. But of course, there are some other approaches regarding energy harvesting. One are thermoelectric generators. These are devices which use the thermal difference on a hot surface or on a warm surface. For example, if you have a motor which gets hot during operation, or some kind of cooling a pipe which gets cold during operation, you can apply your sensor with that thermoelectric generator, and the thermoelectric generator produces the energy. So a very nice example is the water metering or the heat metering, because if you want to monitor your heating, you always have a small thermal difference on the pipe of the heating, and you can use that thermal difference also to power the wireless transceiver, the wireless module. A very more challenging technology, very new, is using mechanical energy. Mechanical energy, on one hand, this might be a vibration, for example, vibration of a motor which is vibrating, or a vehicle, or for example, imagine a railway container which is moving over a railway. You have a certain vibration, and you can use this vibration with a mechanical harvester, and you can generate electricity. And another possibility is to use any kind of deformation. So for example, if you step here on that carpet, Here you're using some slightly deformation of the surface here, and you can use that, for example, with piezoelectric material and generate electricity, for example, supply sensors which are monitoring your environment, monitoring your room, or monitoring your building.
Thank you. So before I'd like to ask Laurent, before I open the questions to the floor, Laurent, we see in terms of demand response, which is a critical function for the future smart grids to deal with large amount of renewable energy. So we see big industrial players already participating in this and so on. Where do you see this going for the home market, the smart home market, for example? Kind of at the moment, like, I don't participate in my home in a demand response action, for example, but would that not be something that's desirable in the future?
Yeah, it's a very good question. I think demand response is demonstrated to be working for large assets, large industries, large battery storage connected to the grid, but there's still a challenge in accessing behind the meter assets. And there are various challenges related to that. One is related to, I would say, this heterogeneous layer which we have in home. And we find the approach proposed by the Commission on data space to be very appealing in a way of harmonizing and simplifying this environment for flexibility aggregator. But I would also say the revenue model is kind of challenging because the several grid operators are not able to properly evaluate the efficiency of the response, and so they do not remunerate it in a proper way. And so there is a lot of ongoing regulation being discussed in Brussels, while I speak today, for instance, a new market design is going to be introduced for that on that specific aspect.
Okay. Wake up call.
Thank you. Thank you. We have a small crisis here at the moment. Whoops.
Alter Vater.
Sorry, we might have to take a couple of minutes
to fix it. Yeah.
Time out here at the moment.
It will collapse on the other side.
Okay.
Just, yeah.
Okay, I fear this is something where IoT wouldn't have helped us at all here. Structural damage.
Structural health.
Maybe I could add, because we talked about data
please.
spaces. Just imagine, you have your health tracker or your activity tracker, and there's a health problem. You go to the doctor. He's not interested in your data from your tracker. He's just looking only on his health file. In a similar situation, we have a gap in the energy system. You have your home devices, you have your home management of heating, of solar and all that. And at the moment, the grid operator is not interested what you do over there. I think he wants to have his data only in his wild. And how could we bridge the two worlds, what we call the smart meter world and the regulated world? That is a discussion about data sharing and a data space for energy.
Okay, thank you. So I'd like to open questions to the floor. So if you have any questions for our panel, please use the microphone in the middle. Yeah, if you don't mind, maybe I don't know whether I could, so that the online audience can also listen in. Thank you.
Morning, guys. Mark Berkeley from LightSource. I'm a firm believer in edge computing as a way of aggregating data locally. And I think if you have harvesting sensors, they won't have the power to have a cellular connectivity, and they will probably be pushing the compute elsewhere, either to an edge device or to the cloud. But we've been hearing for a decade now of siloization and no standardization. Has there been any evolution in standards for connecting sensors to a smart edge compute device or to the cloud?
I think this question is to me. Yeah.
Yes.
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 So actually, I have to say we also power cellular modules with energy harvesting. So if you come to our booth in the Hall 4, we have a 5G NB IoT module which is powered by a small solar cell. The question is always how often you have to measure the data and how often you have to transmit the data. Of course, if you like a permanent 5G a connection, of course you have to use such a solar panel, but if you're okay with sending the data once every 3 or 4 hours, it's okay if you have a smaller solar panel. We even have powered a 5G module with thermal harvesting on a heat pipe. But if you are targeting or asking for the connectivity, of course, Lena had already talked about a new standard, which is IoT, which is an IoT standard, which is very power efficient. It is optimized for lowest power consumption, and I think this is a new upcoming standard which can solve a lot of problems regarding energy efficiency and also regarding robustness, because was designed to be very power efficient and to be very robust, so that you can also do not have a lot of interference with other systems, for example, cellular systems or LoRa systems or Sigfox systems. So there are some new standards coming up which provide that connectivity. And the good thing with IoT, for example, is it is also very, very scalable. You can use only one gateway to get the data from more than 100,000 sensors. So you only need one base station, one edge, and you can monitor a huge amount of sensors.
Okay, thank you.
I may come in as well to the question, because it's a fundamental question. Talk about edge computing, is it more energy efficient? I think a long time back on the sensor networks, I think each device has to take a decision whether to compute the data or to send it into offloading the data. I think that's an energy question. So each device needs sort of an energy management. And the good thing of edge computing is it's a decentralized technology. So you have a decentralized energy management. You can decide whether you can harvest energy, whether you can store energy, whether you postpone a task, or whether you can benefit from energy which is generated by solar, for instance, in the vicinity. If the sun is shining and you know there's a solar panel nearby, you can start ramping up your consumption. So this energy-aware computing, what we call it, is a new research domain also in our research programs on software engineering. And it's coming up and it's becoming a burning issue for your devices, but also for the software engineers.
Very good, thank you.
Okay, yes?
This is Mohammed from Iskra Emco, Egypt. This edge computing issue, now there's some issues regarding the encryption and security. And all this data analytics that can be done at the edge. This will have more computing power and it will consume more energy. So now the device itself will consume more energy. It will not be energy efficient. How to solve this dilemma?
As said, we work on the energy efficiency of the device itself, but as said, each device needs to have an energy management. And also you talk about security. I think if you have a very local communication, I think you can reduce the demands for security, because people have to go physically to the device in order to interfere if it's not connected to the World Wide Web. So I think, as said, the main issue is you have to work on the component level to have a higher energy efficiency. You have to work on the software level to have an intelligent use of energy, to benefit from renewable energy when it's available, to shift your energy consumption to the point, when energy is available. And you have to decide, whether you do the computation yourself or you're offloading it to the backend system, which is powered anyway by normal energy. Yeah. So I think there, we need this new paradigm optimization, what we call orchestration, in terms of computing, energy management, and data sharing, and that is coming up as a challenge. It's a trade-off. You cannot solve everything at the same time. But the more you go to the central communication, to the internet, the more you have to require additional security features. That's also clear.
Yeah, I mean, there's what you'd like to do is you like to learn from your data and maybe train some machine learning models. And there's you might have heard about federated learning, which is a new approach for learning at the edge, where you learn models, machine learning models at the edge on a subset of the data, and then you share in the cloud some of the model parameters without actually disclosing any of the data on which the local model was trained, for example. So there's quite good advances there to demonstrate and enhance privacy.
Yes, sir. Yes, sir. Okay.
Any other questions? Yeah.
Hi, good afternoon. It's Martin Ratcliffe. I work at Vodafone IoT. We've seen over the years that effective regulation actually prompts a lot of innovation. And I'm just thinking we're still at the beginning of IoT sensors, devices. I'm wondering how much you think regulation is really going to help to drive the market and to make sure we have some good energy efficiencies right up front rather than trying to build them in later on.
Yeah, I think that definitely the regulatory issues are very prominent. We talk about the product passport on the one hand, which includes sustainability and energy consumption on the one hand. But we also look at talking about that we're connecting the devices to growing the ecosystems. I think we talk about the Data Act, which gives a mandate to device manufacturers, to be interoperable. That data can be shared across different manufacturers, and that's vendor login in order to grow the sustainability and the use of the devices. And we talk about the Cyber Resilience Act in order to make sure, that in terms of security, during the lifespan of the devices, security issues, updates will be provided, and you have sort of reassurance, you get the security update, and you don't have to release the device because it's not sure anymore. So yeah, I think we are in a very dynamic market, and we try to follow that, and we need your advice as well. It's not us sitting there in Brussels deciding what you have to do. It's a bilateral discussion and an impact. What is needed from your side, and what can we do from our side.
And regarding regulations, I think what I can also add is there's also quite a difference in the European countries regarding regulations for utilities. So for example, in Denmark, they really have strict regulations that above a certain threshold, you really pay for water losses. So they are really, that's an incentive for them to really go into that direction, to make their networks more efficient beyond purely the lost investment or the lost production costs. But in Germany, for example, it's not the case, and also in other European countries. And so I guess here also the regulation needs to reflect more the actual situation that we have right now in terms of water scarcity and energy crisis. But I'm very sure this is to come.
Okay, any other questions from the audience? Okay, so one of the aspects that perhaps I don't know whether this is something maybe Rolf you could elaborate on, particularly the security aspect seems to be something that might down the line affect sustainability. I know this is a little bit off the cuff question perhaps, but if we look at sustainable IoT, for example, we want to have these, you're talking about meters, for example. These are IoT devices that are deployed for a very long period of time. So how do you see, security issues affecting it here? So we see more and more breaches, more and more hacking, for example. So hackers are figuring out ways of breaking current security protection, for example. But if we deploy devices for 10, 15 years, for example, who knows what we're capable of breaking in 10 years' time. So how do you see that, say, being how do you see that impacting on, on some of the technologies that you are working on, or that maybe your company, for example, is developing?
Yeah, so I guess that's also part of the Cyber Resilience Act that you just mentioned, that we have to deal with that. So the sensors are there a long time in the field, and we need to make sure that security standards are really that we keep these security standards. So that's also a very important point if you choose a communication technology, to be sure that you really have end-to-end description and, well, on the long term to be also in Germany BSI conform, to really meet all these regulations, and to choose technologies which are also constantly further developed, because for sure there are always ways how you can attack
IoT systems. So it's not, I mean, if you just have your meter in the base, that's pretty secure. Yeah, it's very difficult for someone to go there and get your data. But if you have hourly transmission, that's really something that you need to take into account very carefully if you design your system. And yeah, as said, I mean, the technologies that we've just mentioned, so for example, IoT, it's really has a very high security standard and is constantly developed further. So this is something that you need to keep in your mind.
Yeah,
Okay.
certainly it's a trade-off between security and innovation. I think the example of the smart electricity meter has shown, we had a super secure smart meter, but it was not used by a wider ecosystem. So why that? Because the standard was too complicated. The overhead was too high. So again, for the next generation, can we separate the security and encapsulate security issues to a minimum and still allowing an open innovation ecosystem? Providing that ecosystem looks at the dynamic analysis and threat analysis of the international and a global level. I think that's needed. So essentially you need, if you have an IoT devices and a group of IoT devices and a standard, you need an ecosystem behind it. Looking at interoperability, looking at new features, to innovate, to provide new services, to connect different ecosystems across energy, water, home and living, and mobility, but also to have a continuous threat analysis. Otherwise, you will have these bad stories in the news, and the people will not have a confidence, in investing in these technologies. So again, we believe not one single company can do it alone. We need it as a common, a joint undertaking, and we try to support open standards and also for security.
Okay. Maybe Laurent, just a follow-up question here. So, in terms of, we were talking briefly about demand response also for residential customers, and so if we, there's a vision of that in the future we might be, residential customers might be able to participate in demand response with their electric cars, maybe with their heat pumps and so on. But now they are, if all of this information is being shared with electricity providers, for example, how do you see, what's the current thinking there also around the privacy and security space from that angle?
Yeah, it's a very good question, and I would say there are other standards which have been added when you come to devices which operate for critical infrastructures and critical functionality of the infrastructure. So there is a network code in the electricity domain which is specifically focused on cybersecurity, and which defines that if you are using a device in a home environment and you use the device for the purpose of balancing the electricity system, then there is an obligation of an extra security layer and auditing of your communication to be able to fit that. What I want to say, very important when you come to demand-side flexibility, is we see this transaction moving to real time. So that's not about exchanging data once a day, it's really exchanging data every few minutes. And of course, this means specific communication being used. So in that specific case, we still use a lot of the broadband internet connection into homes. So that needs to be fully secured end-to-end with security keys and encryption. That is very important. But also, one important element is the fact that a lot of these data are actually owned by consumer under the GDPR Act. And so that means that it is the responsibility of people deploying this type of device to put in place necessary consent and opt-in processes on how they would like to enable data sharing for data space and so on. So there is definitely a large share of complexity which is related to the use case of demand-side flexibility. But I think we have all the tools to make this much more interoperable in the future.
Yeah, but this, I think, of course, the operator needs to access your energy consumption in order to adapt the grid. But again, how many of you have an app from an energy provider on your phone? I think none of you. Oh, you have one at least.
I have one.
So, how many of you at least have a a smart thermostat, an energy app, which is on a private space, or an app from your solar panel or from your electric vehicle. Okay, at least 1/3, a bit more. But you see, we have a very low dynamics at the moment on this market. I think there's still to come. Putting devices outside is something, but you also need the services. At the moment, we have the app market, which is very dynamic. If people using the app, they're sharing services, they're buying the service, it's an incentive. But I think from the innovation cycle, we are far behind, in order to drive or accelerate the transition.
Okay. Any last question from the audience? Okay, then I'd like to close the expert panel. So thank you to the audience for your interest and your questions. Thank you very much to our 4 panelists, Lena, Peter, Rolf, and Laurent online. So thank you for your insights and thoughts on how IoT can be more sustainable and how it can help our world to be more sustainable. So thank you very much, and enjoy the rest of the of Embedded World 2023. Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye, Laurent. Good. Pay attention, pay attention.